So let's look at another example. Okay, Farmer Brown here has 2 hopper bottom grain bins. Have you guys seen these things before? Yeah? Okay, have you ever tried to get inside one before?
No.
Yeah.
Have you?
No, I haven't. But they're lots of fun. They're lots of fun to scream inside of. Yeah, if you get inside of one and scream, really weird sounds. So Farmer Brown got 2 grain silos, right? The larger bin, grain bin, holds 45 cubic meters of grain. And when it gets emptied out to ship the grain off to other people that process it, it empties grain at 1 meter cubed per minute. Okay. The smaller bin holds a little bit less grain, and it also empties at a slower rate. So it holds 30 cubic meters and empties at 0.5 cubic meters per minute. All right. We're going to model the volume of grain remaining as a function of time using a system of linear equations. And just think again, what form of the equation of a line would you use to model this? Slope-intercept, general, or slope point? Slope-intercept, right? Why? What did I say last time? What thing do you look for to know that you should use slope-intercept? There's 2 specific things. A base amount, a starting amount, and also a rate. Do we have that?
Yes.
Yeah, we have an initial volume, a base amount, and a rate. Right? For both. So both of those can be modeled with slope-intercept. Okay? So let's do that. So for the large bin, the volume starts out at 45. And every minute, what happens? 1 cubic meter is lost, right? So I'm going to subtract. So minus just t. Okay, where t is in minutes. Can you tell me the equation for the smaller bin?
30 minus 0.5.
Yeah, good. I start at 30, and I go down 0.5 cubic meters per minute. Good? Can you solve the system graphically?
Yeah.
Okay, let's do that.
Okay, so let's graph this system and find the point of intersection. So our 2 functions were 45 minus x and 30 minus 0.5x. And let's think about some appropriate window settings. X is time, so we would have 0 as our minimum. And our maximum is the number of minutes it would take to drain the grain out of the bins. So let's just put that at about 80 minutes for now. Y is the volume of grain. The least amount of grain that a bin can have is 0. And the most amount of grain any one of the bins can hold is 45 cubic meters, because the larger bin is that volume and it's emptying, right? So it's not going to get any larger than 45. So if we put it 50, we can probably see a good window there. So we go ahead and graph that, and here we go. So this is the larger bin right here. You can see it eventually catches up to the smaller bin and empties quicker. And the smaller bin, because it's emptying slower, even though it starts with less, it actually takes longer to empty. So let's figure out this intersection point. Second trace 5, enter, enter, enter. There we go. So what does this mean? Well, this means in 30 minutes, or after 30 minutes, both bins will have 15 cubic meters of grain. And at that point, the larger bin will pass or have less volume than the smaller bin. All right. Your book also asks, your notes also ask when both bins become empty, right? And if you think about the volume here, right, we start at 45 for the larger bin, and we get less and less and less and less and less, and then we're the same as the smaller bin here, and then we get less and less and less and less. And when we hit the x-axis, that's when we get to 0. Because there's this y equals 15 in the way, I'm going to bring down my graph, let's see, about 15 units. so we can see that point a little bit better. So here's the point right here for the larger bin when the grain bin is empty, right? The line down here below the x-axis is meaningless because you can't have a negative amount of volume. It doesn't make any sense, right? So the maximum you can have is 45. The minimum you can have is 0. So we want to know what is the x value when y is 0, when the volume is 0. That would be our x-intercept here. And you can actually find x-intercepts on your calculator. I'll show you how. If you press second trace, it brings up this menu here. This is where we use to find intersect. Notice it's still there. But there's also this function here called 0, number 2. So we'll go to that guy. And what that function will allow us to do is find this x-intercept here. All right, so to do that, it asks us a question, left bound. That means that we need to take our cursor and put it just to the left of our x-intercept. It doesn't really matter how far it is to the left, but just make sure that the cursor is left of this x-intercept that we want to find. Once we have the cursor in place, just like it is, press enter. And it says right bound, so we take this cursor and we're going to move it to the right, so it's right of that x-intercept. So we move it to the right. There we go. Now it's to the right of the x-intercept. That's the right bound. And then it says guess, which just basically means the calculator is asking you for permission to approximate this x-intercept. So we press enter. And there we go. X equals 45, y equals 0. So in 45 minutes, the larger bin will empty out. It'll have a volume of 0. Pause the video for a moment and see if you can find the x-intercept for that other line. All right, so to find the x-intercept for the other line, we press second trace, and again we go down to 2. You can notice that our cursor is still on the line for the larger bin. So to make it go to the line for the smaller bin, you can press up or down, and you'll notice that this equation up here changes. So you press up, and there we are. Now we're on the line for the smaller bin. You can see the cursor jump from line to line, right? So left bound, I put the cursor just left of that x-intercept. Here is probably good. And then right bound, I go just to the right of that x-intercept. Come on. There we go. And then enter again, and there we go. So the smaller bin actually takes an hour, 60 minutes, to empty out.